In this video, I am covering exercises related to material covered in Chapter 18. As usual, after seeing the question, you can pause the video, do the question on your own, and then check my answer. So first question, which of the following compounds is a good dienophile? Good dienophile is compound with double or triple bond that has an electron withdrawing substituent on it. And so A would be good dienophile because it has double bond with carbonyl group substituent. B is not triple bond, but that one has two methyl groups. Those are electron donating, not electron withdrawing groups. C is not very good dienophile. Nitrogen that is a little bit removed from double bond, well, one carbon removed from the double bond, is an electron withdrawing group, but it withdraws electrons through inductive effect, and because of the distance, effect is relatively minor. So that would not be a good dienophile. And D is not a dienophile. A carbon-oxygen double bond in some cases could act as dienophile in these other reactions, but those are first advanced concepts, and those reactions are not as common. We are really looking for carbon-carbon double or triple bond with an electron withdrawing group on it. And the only one of them is A. All those others are not really good dienophiles. Next question, which of the following dienes is the most stable? So you need to classify these dienes because stability of the dienes is alkenes, the least stable, isolated dienes, intermediate stability, and conjugated dienes, the most stable. So compounds A and B are alkenes, and so those have very low stability. C is an isolated diene, and D is conjugated diene. So that's the one that is the most stable. Next question, predict the products of the following reaction. So here we have cyclic compound with oxygen in a ring, 8-membered ring with oxygen and two double bonds. Oxygen is next to one of the double bonds, which means that there is electron delocalization between oxygen and that double bond. So oxygen is donating electrons to the double bond through positive resonance effect. Both double bonds of the ring are affected by oxygen through inductive effect. Oxygen exhibits negative inductive effect and withdraws electrons from both double bonds. Now, double bond on the left next to the oxygen experiences both inductive and resonance effects of oxygen. And since resonance effect is stronger, the net effect is electron donation. So that double bond is activated. Double bond on the right experiences only negative inductive effect of oxygen, and so that double bond is deactivated. So double bond on the left has higher reactivity. And that's the one that will react with hydrogen bromide. That means that the correct answer is either A or B. Question is only what is the regioselectivity. And for that, it's the best to draw reaction mechanism. So first, draw two resonance structures that show electron donation from oxygen to the double bond, and then reaction with hydrogen bromide occurs in such a way that carbon that has increased electron density donates free electron pair to form bond with hydrogen, and that breaks hydrogen bromine bond. And then in the second step, bromide anion reacts with second carbon with electrophilic carbon to give the final product. And now that you have identified the final product, you match it with 4 possible answers, and correct answer is A. Next question, which of the following alkenes would you expect to react the fastest with water in the presence of sulfuric acid? And those are 4 alkenes. Here are structural formulas. So first one, ethene, has no substituents, so it has default reactivity. Second one has 2 electron withdrawing substituents, fluorine and nitro group. So electron withdrawing substituents reduce reactivity of double bond towards electrophilic addition. so that one will have even lower activity. Third compound, tetrachloroderivative, has 4 electron withdrawing substituents, so that one has even lower activity. Again, electron withdrawing substituents, electron density of the pi bond is reduced because of the, in this case, negative inductive effect of 4 chlorines, so very low activity. The last one has 2 methyl groups. They donate electrons through positive inductive effect and increase reactivity of the double bond. Another way to look at it is that 2 methyl groups will stabilize intermediate carbocation by making it into tertiary carbocation. So that one has the highest reactivity. And here are shown groups in red that reduce reactivity of the double bond, and in green those that increase. So correct answer is D. Next question is, what is the product of the following reaction? And in this case we have a Diels-Alder reaction. So what you're supposed to do is draw 2 reactants vertically with their carbon chains pointing vertically, so that you can push arrows clockwise, counterclockwise to form bonds of cyclohexene ring that will be formed, and then that way you can figure out the reaction product. Note that in dienophile, the alkene, 2 substituents are trans. That means that in the product, 2 substituents will also be trans. They will be trans relative to each other in the ring. So it's trans product. And so you match the product with 4 possible answers, and you can see it matches answer B, so correct answer is B. And then some free response questions. So another Diels-Alder reaction. So to answer that one, again, you draw 2 carbon chains vertically and make sure now that regioselectivity is correct. Since each diene and dienophile have substituents, there is possibility for different substitution pattern in the product. In this case, competition is between 1,3 and 1,4 products. So 1,3 and 1,4, actually, if you use IUPAC nomenclature, it will be 1,4 and 1,5. But when we look at 2 substituents, they are relative to each other, 1,3 or 1,4, or to use that mnemonic, meta versus para. So it's para substitution pattern. Remember, we use in this case ortho-para rule, that even though we know that these compounds are not ortho-meta-para, those are benzene rings. So 1,3 product is never formed, it's always 1,2 or 1,4 product forms. And this is case where 1,4 product forms. And finally, predict the product of the following reaction. So reaction of conjugated diene with hydrogen bromide at high temperature, at 40 degrees Celsius. So those will be thermodynamic reaction conditions. And under thermodynamic conditions, addition is 1,4. In this case, I showed reaction as concerted reaction. Actual reaction is probably not concerted, probably proceeds through carbocation, but this kind of is a quick way to draw, to figure out what is the product. So 1,4 addition. And this completes chapter 18 exercises.